Hi, I'm Shawn, the air quality guy, and today I'd like to talk to you about vapor pressure and a construction wall assembly. Behind me I have a mock-up of your typical poured foundation wall, and we'd like to talk about how moisture migrates from the outside of the wall and migrates through the construction assembly, getting inside. This is what causes typically your damp basements. Here we have a typical concrete wall assembly. We have an 8-inch by 20-inch footing, we have a key, and we have a poured wall, typically 7 foot 10 high. On the outside of our wall, we have a conventional weeping tile. In this mock-up display, we have a lot of moisture migrating through this wall assembly, coming in contact with the organic material found inside our homes. Once again, this is what causes humidity in typically most basements in Canada. And here to tell us about how to improve a foundation wall assembly is my friend Rick from Great Outdoors. Hello, Rick.
Hi, Shawn.
Why don't you take a moment and tell us the defenses you've used in this foundation application?
Yes, Shawn, this mock-up shows a foundation wall with several cracks. Okay, we excavate down, remove the fill, find a damaged weeping tile. Okay, once we've removed the weeping tile, we install a new 4-inch perforated weeping tile with a sock on it. Shawn will explain what the sock is about.
Well, typically if you have a percolation factor or soil with a lot of clay-based material, the silt or sediment found in that soil migrates into a weeper. It begins to fill the holes in the weeper, decreasing its productivity. What we install nowadays is a weeper with a geodetic material sock over it. This keeps the silt from entering the weeper and lets the weeper do its job. Go ahead, Rick.
At this point, we would repair the crack with hydraulic cement, install a blue skin paste on top of this repair. We could then damp-proof the wall. We install a system platon, which is secured to the wall as well as the footing. Once we've completed that, we make sure to have our termination strip, which is installed tightly and caulked.
Rick then chooses to use a backfill material of granular. This increases the percolation rate of the moisture that migrates through the assembly. What we're trying to do is get any surface moisture that's here down and into our improved weeper system as quickly as possible. Rick, why don't you explain the airspace behind the system platon?
The reason for the airspace, this gives us two things. If by any chance some water were to make its way behind the platon, the dimples here would allow it to come down and make its way to the weeping tile. At the same time, the dimples give us our airspace, which stops any migration, humidity, to make its way to the wall.
So once it's backfilled and properly graded, that is to say there's a slope, you typically, from what I understand, put a 10-inch mantle of topsoil?
Well, we most of the time will put a good 6-inch of clay as a last barrier for water, and then we give our area of topsoil, always keeping in mind it must be a positive grade away from the home.
Now, the National Building Code of Canada requests an 8-inch space between the top of your foundation and the top of your finished grading. That is to say, through capillary action, if we have our finish too close, capillary action would pull moisture in and affect your rim. So we always like to see a minimum of 8 inches from the underside of the construction assembly to the top of your finished grade. Thanks, Rick, for coming in.
Thank you, Shawn.